Mic check. Probably should have got the notes program up ahead of time. Okay, so the goal here is to get through questions 6 through 10, and then field any questions you have beyond 6 through 10. So that's exactly what we're going to be up to here. So we're starting with question 6. Okay, so for question 6, use the first 4 non-zero terms of Maclaurin's. Sorry. Find the first 4 non-zero terms of the Maclaurin expansion for the function f of x equals x sine 2x. So f of x equals x sine 2x. So first of all, we know that this is a Maclaurin polynomial, so we don't have to worry about doing this through derivatives. We just have to fashion or craft our series using a known series for sine. So we'll start off with sine. So sine of u, that's going to be equal to the odd terms. So x to the first power minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And then that is negative 1 to the n, u to the 2n plus 1 on 2n plus 1 factorial. So I'm noticing that these should be u's. I mean, honestly, they could be an x, but I think it gets confusing when you substitute x for x. So I like to use a u. Right? The next thing we're going to do is we're going to change all the u's into 2x. So that gives us 2x minus, and let's just leave that in there for now. Did I mess up? That should be a minus now, right? Minus 2x to the 7 on 7 factorial. Again, the only thing you want to mess around here with are those u's. That's 2x to the 2n plus 1 on 2n plus 1 factorial. And that's the very first thing to work out. Okay, now that you have that, it might be a good idea to expand a little bit, simplify a little bit. Let's get the 2, let's take the x and take it out of the parenthesis and see what we get. Shoot. So we got sine 2x. That's going to be equal to, well, 2x there. That's going to be 2 cubed over 3 factorial x cubed. Remember what I said, until you figure things out, you can leave it as a cube. No one's going to mark you wrong. That's 2 to the 5th power on 5 factorial, x to the 5th power, 2 to the 7th power on 7 factorial, x to the 7th, negative 1 to the n, 2 to the n plus 1, no, to the 2n plus 1 on 2n plus 1 factorial, multiplied by x to the 2n plus 1. Okay, things are looking great. Now we just have to multiply every term by x. So x sine 2x, that's just an increase of power for every term. So instead of 2x, we now have 2x squared. Instead of x cubed, we have x to the fourth. Instead of x to the fifth, we now have x to the sixth. Instead of x to the seventh, we now have x to the eighth. And now as I'm reading this, I don't see that we have to find the general term here. So I'm actually just going to leave out the general term. Although it would be 2n plus 2, right? And that takes care of question 6. It's probably much greater detail than you would ever go into if you're writing this by yourself. Michael.
You don't need to simplify it.
Nope. If you do decide to simplify, you better simplify correctly. Because that's
On the multiple choice, it would show up simplified, right?
in the multiple choice, it would show up simplified, yeah. That is an excellent point. Okay, so if that's it for 6, let's take a look at 7. We need a third-ordered polynomial for cosine centered at pi over 3. Now, when it says at pi over 3, sorry, what's going on here? When it says at pi over 3, what that really means is centered at pi over 3. We're changing the center, so whenever you change the center, you need to go through Taylor's theorem. We're changing the center. We need to use Taylor's theorem. We need to take derivatives. And this is one of those times where it should be signaled clearly to you that you're meant to take derivatives. So this is supposed to be a little painful. But notice that the function that you're taking the derivative of is a pretty innocent function. It's not going to have crazy derivatives. So yeah, no one's going to ask you to take a bunch of crazy derivatives. Okay, so let's do this. If f of x equal to cosine x, and that means f of pi thirds is equal to 1/2. F prime of x is going to be negative sine x. So f prime of pi over 3, that's going to be equal to root 3 over 2 negative. F double prime, that's negative cosine of x. So f double prime of pi over 3, that's negative 1/2. And we do need a third order, right? So f triple prime of x, that's back to sine x. So f triple prime of pi thirds, that's positive root 3 over 2. Okay, so we have everything we need to set up Taylor's polynomial, or the Maclaurin polynomial. No, this is a Taylor polynomial. We have everything we need for Taylor's polynomial. Let's just write this down for a third-ordered polynomial. So we have f of x can be approximated by f of a plus f prime of a, x minus a, plus f double prime of a on 2 factorial, x minus a squared, plus f triple prime a on 3 factorial, x minus a cubed. Now, does this say polynomial? Yeah, it says polynomial, so we're meant to actually just stop right there. You don't need a plus dot dot dot. Right? think the answer key does have plus dot dot dot. We don't need that. I'll fix that for next year. Okay, so let's substitute what we know then. F of x is going to be approximated by, help me out, was that 1/2?
Yeah.
That's 1/2 plus negative root 3 over 2 x minus pi thirds plus, that's a 1/2 and a negative 1/2 x minus pi thirds squared plus, that's a root 3 over 2 and 1, I should preserve order, I'm sorry. That's 1 over 3 factorial, which is 1/6, root 3 over 2, x minus pi thirds cubed. Now, if you left it here, this should be marked correct. There's nothing wrong with this polynomial. You could just leave it there. The answer key took it upon themselves to simplify. You don't have to simplify this. Again, you don't have to simplify this, but the answer key did. So just to respect the answer key a little bit, we'll just factor out that 1/2. That's that 1/2 there. So we'll get a 1 minus root 3 x minus pi thirds minus 1/2 x minus pi thirds squared plus root 3 over 6 x on pi thirds cubed. Again, you're not under any obligation to factor out that 1/2. It's perfectly fine without it. Yeah, that's totally fine too. Okay. Questions on 7? Okay. There's 7. Let's take a look at 8. Another Taylor polynomial, second order, to approximate cosine of pi over of 0.2. Okay, so 0.2 is close to 0. So we're going to center at 0. All of that means we can use the Maclaurin polynomial. And you don't have to go from the ground up. You don't have to take derivatives because we're going to center at 0. So all we got to use is a Maclaurin polynomial for cosine centered at 0. So cosine x can be approximated by, okay, cosine's an even function, so 1 minus x squared over 2, right?
Mr. Bird, so you can use the Maclaurin polynomial instead of the Taylor because it's centered at 0?
Because it's centered at 0, right? Or you, let me put it this way. You don't have to construct the Taylor's polynomial because we're centered at 0. Okay. Okay, so that means cosine of 0.2, and I find it easier to do this with a fraction. So cosine of 1/5 is approximately equal to 1 minus half of 1 over 25. That's 1/50th, so 50 over 50 minus 1 over 50, that's 49 over 50. So cosine of 0.2 is approximately equal to 0.98. So you don't have to use Taylor's theorem because we're centering a polynomial at 0. Yeah.
Since it's the second order, don't you have to do 3 terms?
Well, second order means that the highest power is supposed to be 2.
Oh.
Regardless of how many terms. I mean, you can have a second order polynomial that only has 1 term. Any questions on 8?
So on the test, A is going to be close to 0 too?
It should be close to 0. Yeah. I don't actually like the way this is worded. It really should tell you the center of the polynomial, but let's take a look at 9.
So where do you get these questions from?
I use a good 24 sources for all of these questions, so for me to remember, I don't know anymore. I'm pretty sure this one is from.
Are they mostly review books?
No.
No.
That's not from a review book. Although I could see that in a review book, but I'm almost dead positive I did not get that from a review book. Number 9, Taylor polynomial order 3 to approximate e of 0.4. And again, 0.4 is reasonably close. 0.4 is close to 0, reasonably close to 0. So we're just going to use the Maclaurin series. You're probably free to use any series you want. Center it at any place you want. But you're going to have a hard time computing e to increasing powers. So just stick with the Maclaurin series if not really specified. That's probably a good way to go here.
What if you was like e squared? Then should we still use Maclaurin, or is that too far?
Well, it depends on the order. Okay, if it's the first order, second order, you can probably square e or cube e. That's not that big a deal, although it's time consuming. But you usually shouldn't be required to do that. 9. Oh, we are on 9. Okay, so E series, we want third order. So e to the x can be approximated by 1 plus x squared. No, 1/2 x squared, right? Plus 1/6 x cubed. Let me know if I have that right. That's right. So e to the 2/5, that's going to be approximately equal to 1 plus 2/5 plus 1/2 of 4/25 plus 1/6 of 8/125. Okay, you can stop here. This is the answer.
It does like 5 something over.
Yeah, this is the answer. No need to simplify. Why do I say this is the answer? Well, because you don't need anything beyond a 4-function calculator to solve this. If you get it down to a form which you can compute with a 4-function calculator, you're done. Okay. Do you want to simplify this? Not particularly. Yeah, exactly. There's no point. This is the correct answer. Okay? Don't waste your time simplifying when you don't need to. And even more importantly, don't put yourself at risk of making an arithmetic error when you don't need to. That's 9. Number 10. We want the Maclaurin series for cosine of negative 2x. We want that in sigma notation. So really the only thing we're interested in is the general term, right? So we don't really need all the terms here. Let's just go with the general. Let's just go with 3 terms here, just to save us a bit of time. So cosine u should be approximated by 1 plus u squared over 2 minus u squared over 2 plus u to the 4th over 4 factorial plus negative 1 to the n, u to the 2n factorial. Again, we're only really interested in that general term because we have to write in sigma notation. And here our n is starting at 0, right? That's going to be important information too. So that means cosine of negative 2x, that's going to be approximately equal to 1 minus negative 2x squared over 2. Again, I don't really care about this term. I only really care about the general term, so I'm not going to worry about simplifying that. Plus negative 2x to the 4th over 4 factorial plus, so we're getting a feel about how things are going to go down, negative 1 to the n, negative 2x to the 2n on 2n factorial. N is still starting at 0, 1, 2. Okay, from here, let's just work on that general term because that general term is what our answer is going to be. Negative 1 to the n. So we can simplify this. Negative 2n, negative 2 to the 2n, that's equal to negative 2 squared to the n power, right? That's 4 to the n. On top of 2n factorial. And then we get x to the 2n. In other words, cosine of 2x bless you, can be approximated by the series 0 to infinity, negative 1 to the n, 4 to the n, 2n factorial, x to the 2n. Okay?
Mr. Terry, so it's optional to simplify these part, right?
Which one?
Like, would you be able to just leave it as negative 1 to the n, 2 to the 2n, and then x to the 2n?
Negative 2 to the 2n. But I have a feeling this is meant to be a multiple choice question.
Oh, okay.
So you're going to have to get a little bit used to simplifying that as well. Any other questions specifically on 10? Okay, let's open it up. Is there anything that you want to look at in exclusive of the 6 through 10? 5? Okay, let's take a look at that. Now, good practice for number 5 would always be to write out the series. Again, good practice is always write out the series. Cannot stress that enough for 5. Write out the series. So when n equals 0, or actually I'm going to write it down in sigma. That's 0 to infinity, negative 1 to n, x minus 3 over 10 to the n power. So always a good idea just to write out the series. So let's write out that series. That series is when n equals 0, well, we get 1. When n equals 1, we get minus x minus 3 over 10. When n equals 2, we get positive x minus 3 over 10 squared. So we should be seeing that this is actually a geometric series. Don't care about the general term. That's not really what the question is asking for. So this is a geometric series. First term is 1. The geometric ratio, negative x minus 3 over 10. So all we need to do is figure out where this converges. And as a geometric series, you know that the absolute value of the ratio must be exclusively less than 1 for convergence. Okay. So the absolute value of negative x minus 3 over 10 should be less than 1. You don't need that negative sign anymore. The absolute value of x minus 3 over 10 should be less than 1. Okay, so let's try and solve this from here. My advice to you right now is I would always multiply and divide right now. So I would multiply both sides by 10. So let's do that. 10 times that times 10. What do we get? We get the absolute value of x minus 3 is less than 10. Now that I have that, I can go ahead and start putting it into my notation here. Negative 10 should be less than x minus 3, which in turn is less than 10. Shift everything by 3. You get negative 7 is less than x is less than 13. So what do we have? We have the series converges. Oh, I'm sorry, we didn't get the sum, right? The sum is equal to the first term, which was 1, over 1 minus, x minus 3 over 10. Naturally, this is plus and a plus. So we have 1 over is that 10 plus x minus 3 over 10. And so the sum is equal to 10 over 7 plus x. Series converges for x between -7 and 13. Sweet. That is it for 5. Anything else you want to look at? Okay, I guess we're done then. Let's wrap it up.